Hey everyone, this is your video for the lesson notes for 2C-5 and 2C-6. 2C-5 is all about y equals mx plus b, and 2C-6 is about the same thing, linear relationships. One just gives an equation and the other one we just call it by name. So everything we have on this page is going to be using y equals mx plus b to graph linear relationships. So it really is basically the same thing. That's why I did it in one lesson. This equation right here is called slope-intercept form. And I want you to kind of copy these notes down on top of the paper that you're gluing into your journal so that you have these notes next to the paper in your journal. So it is called slope-intercept form. This formula is going to be found on your star chart, and so you won't have to memorize it, but I promise we're going to use it so much that you are going to memorize it. You just have to make sure that you know what the letters mean. So first of all, down here, go ahead and just kind of rewrite y equals mx plus b. We're going to draw an arrow to the m and an arrow to the b. Now the reason that it is called slope-intercept form is because we have a slope and an intercept. The m represents our slope, and the b represents our y-intercept. So since we have a y-intercept and a slope, for instance, this one right here says 3 and 1, you can use these numbers to help draw your line on the graphs. So if our y-intercept says 1, I'm actually going to start with the y-intercept because it's kind of like my initial value, my starting point. It's also a nice place it actually shows me a specific spot on the graph to start. So I'm always going to start with the y-intercept. So I'm going to draw a little arrow reminder to say start with the y-intercept. All right, so if I'm going to start with 1, I am going to put a little dot right here on the 1 on the y-axis. You're going to have to count because there are no numbers for these. And I do have to know that this is my y-axis and this is my x-axis. And then from the 1, I am going to use the number next to the slope to tell me how to move. So since my slope says 3, I use that slope to tell me how to move and so that I can put a new dot. And so I know that slope is rise over run. Just going to kind of make some notes here to the side for myself. And if slope is rise over run, I have a plane 3. What I'm going to do and what I'm going to have you guys do is put 3 over 1. So 3 over 1 like this, to where my rise is going to be 3, my run is going to be 1. If I would have simplified this number a little bit further, 3 divided by 1, I would get 3, plane 3. And then I would have known that my slope was 3, which is exactly what they told me. So I can use this method by putting a whole number over 1 to figure out my rise and run. So rise 3, 1, 2, 3, run 1 to the right. Remember, we're always running to the right. And at this point, I have my second dot. I can go ahead and create my line by connecting the dots. I can kind of go further and then just those 2 dots so I can show the entire line across the graph. And I'm going to put arrows on the ends of them to show that it's a continuous line. It's going to go on forever and ever. Okay, the next one says I have a -2 as my slope and a 3 as my y-intercept. So remember, we start with the 3 as your y-intercept. So I'm going to go up to the 3 on the y-axis, start there. And I notice that my slope is going to tell me what to do. Now again, I have this whole number or an integer. It's not a fraction like I'm used to for rise and run. So what I'm going to do is put -2 over 1. So it's going to tell me that from the dot that I had originally, I'm going to go down to 1, 2, and slide over 1 to the right. Remember, we still go to the right. And at this point, I have a -2 slope. So you might notice that this slope said it was 3, a positive 3, and I did create a positive line. This slope said it was -2, and I did create a negative line as a slope. All right, number 3. This one looks a little tricky. Remember that all these equations are graphed or are written in y equals mx plus b, y equals mx plus b, y equals mx. Where's the plus b? Well, I'll tell you. It is plus 0. If something is plus 0, you don't have to write it, and so they didn't. Whenever the y-intercept is not there, it's not just plainly obvious, it's because there's not one, or technically you're just going through 0. All right, so here's our y-intercept. Our slope was -5, so if I were calculating my rise and my run, I would put this -5 here over 1. Oops, sorry guys. And I would be going down 5 over 1 from the original dot that I made. Down 5. 1, 2, 3, 4, 5, and over 1. There is my new line. Well, not new line, but a line in general. You might notice that my line is not perfect, and if yours is not perfect, it's okay. Try pretty hard to at least draw a line through the dots. It does not have to be perfect, but I do want it to be very close to it. Okay. Moving on to number 4. Again, we are in y equals mx plus b, where we have y equals mx plus b. And you might notice that there's something missing, and it looks like it's our m. It looks like our m is missing, but we know from our equations unit that always in front of a variable is invisible 1, which is nice to know because that means my rise over my run would be 1 over 1. So if I'm going to start with my y-intercept like usual, this y-intercept says -2, which means I'm starting at -2 down here. And then my slope was 1. I consider it 1 over 1 because I know that 1 over 1 was that 1 that I was talking about, which means I rise 1, run 1. So from the dot that I created with my y-intercept, I go up 1, over 1, make a dot. And I honestly could continue these patterns anytime I have room. Up 1 over 1, up 1 over 1, up 1 over 1. If I really wanted to get, kind of make a really good line, that's what the slope does. That's what it helps you to do. Okay, let's move on to number 5. This time I have decimals, so it looks a little funky. I am going to change this decimal back into a fraction. So anytime we have slope, it's a little bit easier to read when we have a fraction like we're used to because we call it rise over run. So -2.5 is the same thing like saying 2 1/2. So if I create that into a mixed number, or I'm not a mixed number, sorry, an improper fraction, it would be, hold on, I'm thinking guys. I'm going to divide by 2. It should be 5 over 2. Okay, 5 over 2. All right, and then it says my y-intercept is -1.5. Now, making this number into a fraction isn't going to help us at all because we're still going to be trying to figure out -1.5 along this y-axis right here. I know that my -1 is here and my -2 is here, so I'm going to go ahead and draw a dot right in the middle of those two places for my y-intercept. There it is, and then from this dot, it says that I have to go up 5 and over 2. Now this is going to be a little bit tricky, so pay attention. When I go up 1 unit, I'm going to end up right here in the middle of this box for 1. That means I am here for 2. Remember, I'm rising. So 1, 2, 3, 4, 5. Run 1, 2. My dot is right here. You will not run into a lot of decimals for your y-intercept. That's why this graph is so funky. Remember, mine is not perfect. Yours doesn't have to be perfect either. But like I said, you won't run into a ton of decimals for your y-intercepts. I just wanted to throw one out there in case you ever do. All right, last little equation problem. I always start with my y-intercept, which says 2. So this is a nice starting point for me. It's like my initial value, and it's a nice place to start whenever you're drawing your line. My slope tells me, remember my slope is in the m spot. It is right here next to the x, y equals mx plus b. So if it is in the m spot, 1 over 4 is nicely, and in a fraction this time, it's my rise over run, so I have 1 over 4. From this dot that I created, not any other dot, but from that dot, I'm going to go up 1 over 4 to create my line. If I ever needed to go backwards, I would have continued that little pattern back down this way, so kind of down and back, just in case you ever need to create the line in the different direction. Okay, so you will notice that the bigger your slope is, so this one was, you know what I noticed? I did not do this one as negative. I did this one as a positive 5 over 2. It should have been down 5 over 2. Well, sorry about that, guys. I should have went down 5 over 2 and made a negative line. But that's okay. We'll leave this and we will rewrite this above as just saying y equals 5 over 2x minus 1.5. And we're going to just exit that out. Just so our notes can be still accurate. All right, let's move on to this word problem here. It says the school spirit club is selling t-shirts for $10.50 each. Write a function to represent the situation. So first of all, our function is a linear relationship. It's just kind of saying that something is working with something else. Kind of like that's what functions do. They are functional, they work with each other. So this, what was working together is this t-shirt. We were selling t-shirts and we're paying money for them, right? Or we're trying to earn money for them. So if we're selling t-shirts, it looks like we don't have a starting value. We're probably starting at 0, like we have not sold any t-shirts yet, but we are going to be selling them for $10.50 each. So I could say y, which is the number of money we make, is going to be 10.5 times x, the number of t-shirts we sell. Now it says make a function table to find the total of 1, 2, 3, 4, 5 t-shirts. So if I was selling 1, 2, 3, 4, 5 t-shirts, which is x, it would be basically if I was putting a 1, a 2, a 3, a 4, a 5 right in that spot for the x. So I am going to do that here. I'm going to demonstrate that. So I have 10.5 times 1, and 10.5 times 2, and 10.5 times 3, and so on, until I get my answer. All right, and then I know that 10.5 times 1 is $10.50, so we would have made $10.50. If I sell 2 t-shirts, we have, let's see, $21. If I sell 3 t-shirts, we have $31.50. And if I sell, 4 t-shirts, we have $42. And if I sell 5 t-shirts, we have $52.50. So this wanted me to make a table, so I did. That's how your functions will, oh my goodness. I did not realize y'all couldn't see everything I wrote. Sorry. Pause your video if you need to get that in. The next thing says to graph the function. And is the function continuous or discrete? What this means is continuous or discrete. These lines that we drew above are continuous. We could plot any point. We could try to plot a point right here or just have a bunch of decimals to it. But what's going to happen is we're not going to be able to sell 1.5 t-shirts or 2 3/4 t-shirts. We're not going to be able to do that. And so because we're not going to be able to do that, we're going to have very discrete points along this graph down here. So we had $0 for 0 t-shirts. 1 t-shirt was a little bit over 10. 2 was just a little bit over 20. 3 was still just a little bit over 30. And 4 was just a little bit over 40. 5 was just a little bit over 50. And so that is my line. For the next part of this video, I am going to be completing part of 2C-6 on your independent practice. So the top of this paper looks like this, 2C-6. I'm going to be talking about some of the graphs at the bottom. That way it might make the top part just a little bit easier for you. So first of all, we have a graph that says temperature and elevation by 1,000 feet. It's talking about elevation and temperature, so I'm guessing the temperature is going to be really or hotter when the elevation, like the temperature, if we kind of go in elevation, oh, it's not really here. Oh, okay, so the further we go in elevation, the temperature will drop because the higher we go, the colder it gets. So remember that these are kind of tricky to read, but you do read them kind of like a story. It's telling you a story. So 16 says, what was the temperature at sea level? Sea level means there's no elevation. Elevation would be here. So the temperature would be at 40 degrees. So the first one was 40 degrees, and it is Fahrenheit. And then it says then at 20,000 feet. So you might forget that we were talking about in thousands, but that would be this number here. and our temperature is way down here at negative 20 degrees. So we went really tall into the mountains, and our temperature dropped drastically. And then it says, at what rate did the temperature change from here? And it kind of tells you degrees by 1,000 feet. So this is where slope comes into play. You could use these 2 points here. Remember, they have to be perfect. You're going to go down, what is that, down from 40 to 10. So I would say down 30. And then over from 0 to 10, so that's 10. So it looks like we're going down 3 degrees every 1,000 feet. Okay. And then it says about what is the elevation, what elevation was the temperature of 0? So if the temperature is 0, we're looking for the elevation, which is here. It looks like it's in between 10,000 and 15,000 feet. So I'm just going to call this 13,000 feet. All right, let's look at this graph. It has vacation travel. So if the distance goes up, the time gets longer. Interesting. So I guess that these people are traveling, and the further they go, you know, of course, the time goes on, which makes sense. It says, what is the rate of speed from 0 to 3 hours? So in this little range right here, from 0 to 3 hours, we're looking for the speed. The rate of speed, or the speed, is the rate of change, which we consider the slope. We're still going to do rise over run. So I would do up 0 to, I think this should be 150. So my rise would be 150. My run would be 3. Remember, I'm calculating by the numbers that is going on the axis. So 150 divided by 3 is 50. So from the first 3 hours, they went 50 miles per hour. Then it says, what is the rate of speed from 3 to 4 hours? And they didn't go up at all. They stayed stagnant. And remember, we know this slope is going to be 0. You could put an actual 0, but I don't want you to get it confused with an O or anything like that. And the last one says the rate of speed from 4 to 9, so here to here. So I can go find, looks like this point and this point are actually the only perfect coordinates. So I'm going to be going up and over. So let's see how much we went up. I guess it's going up by 50. From 150 to 450, because I think that right here should be 450, which would be going up 300. And then over from 4 to 9, which is 5. That is 60. So see how the slopes changed? This one went 50, and this one was 60. What's happening is she's going faster here, stopped here, slower here. They're still going, but they're not going as fast because the line isn't as steep.